Hey folks, we're going to solve a problem here called PathSum. It's LeetCode number 112. So basically we're given a binary tree, so the tree is binary, and we're looking for a root leaf path. In which the nodes add up to a particular target, such as this one, 11. So here's an example of a root leaf path, 5, 3, and 1. Oh man, that. So this is one root leaf path, and the sum of this path is 5 and 3 and 1, which make 9. So 9 is not a match for the target. In fact, it is this root leaf path right here, 5 and 3 and 3, that makes 11. So this root leaf path is a path that adds up to the target. And if we find a root leaf path with the target sum, then we return true. Otherwise, we return false. That's what the function should do. So the strategy we'll use will simply be, let's say we have a root node here and a target sum. We'll just call a sum here. We're going to use DFS, depth first search. So DFS means we visit, we start at the root, then we go left, and then left here again. So we've traversed this path. Then if this isn't a match, we'll go up and then go right and so on. If that's not a match, we'll go up again and we'll go back up here and then go down here. So that's DFS. We're going to visit the nodes that way, the root leaf paths that way. But as soon as we find a qualifying root leaf path, we're just going to go ahead and return true. So the way we're going to do this is we're going to keep track of the sum of the current path as we go down a root leaf path. And we're going to accomplish that using a parameter, a function parameter, which you'll see pretty soon. So let's start off with a vanilla implementation of DFS. So I like to call my graph visitor functions visit. Let's assume that we won't be passing a null node. We'll be passing an actual node. So that means before we visit a child, whether it's the left or right child, we're going to check to see if such a child exists. So if node.left, then go ahead and visit the left child. Same for the right. Just like that. So now we want to, call that on the root node for 1. And basically, if we're past a null root, let's just go ahead and return false, because the visit function here assumes that we won't be passing a null node. That. So we're going to add a running sum parameter like this. And the first thing we're going to do upon visiting a node is to add the node's value to the running sum. So it looks like this. Then we're going to propagate that running sum to the recursive calls. That. Once we're at a leaf node, then we're able to compute, we have the full sum of the path. And we want to compare that to the target sum. So after we add the node's value to the running sum, let's check to see if we're at a leaf node, and if so, compare the running sum to the target sum. So that looks like this. like that. So let's make use of this return value here. So let's say we're here, and we go down, we visit this child, and we go all the way down, and we discover that there's a true, that such a path exists in this direction. So if that's true, then this call will return true, and we can just return true for the whole thing. If, however, we go down this direction and we couldn't find anything, then we're going to want to go down here and return the result from exploring this side of the tree. So let's go and do that. Just combine these. I forgot to modify this. So basically, starting out, when we're at the root, the running sum is going to be 0. So pass it over here, and we're going to return the result of this function. So that should work. Let's go ahead and pop that into the code here. Reformat it a little bit. That should work. Let me just test it real quick here. And there it passes. And I experimented a little bit earlier. So there you have it. That's the code. Enjoy.